So a few weeks ago, I was in my kitchen around midnight, and I looked at my microwave oven, and I saw this. And it looks a little bit weird to me that the clock is saying 24 hours and 0 minutes. Shouldn't it be 0 hours, 0 minutes? So I thought, is this a bug? Is my German piece of solid engineering actually buggy? So I started to look into this and see, is this really an issue or not? And can I learn something more? And I thought it would be pretty quick, but turned out time is pretty complex when you start looking into it, and especially when it comes to programming and software development. So I'm not going to bore you with all of this. I'm going to focus on two things today: calendars and time and date representations, and especially how it relates to C++. So beginning with a calendar. What is a calendar? It's typically a way to count the time elapsed or the number of days elapsed since a certain epoch, and also to keep track of leap seconds and leap days. And did you know that there's also leap weeks and leap month in some calendars? Like the Chinese calendar has an extra month in some years, because otherwise the moon and the sun and your time will be out of sync. Daylight saving time and time zones, and you all know this is a pain when you do software development. And of course, there's a lot of bugs related to this. This happened last year. It's the leap day, February 29, when the payment system in the grocery chain ICA was down because, oops, they didn't think about leap day. So expensive mistakes. And there's also other fails when it comes to calendars. And this is actually my favorite. Did you know in Sweden in the 1700s we did have a month where we did have one occurrence of February with 30 days, because we decided to switch calendars, and then we started to fight a war, so we kind of forgot to finish the switch. So 12 years later we realized, oh, we forgot. And the government said, or the king rather said, okay, what the we just get to go back to the old calendar again. But to get in sync with the Julian calendar, they had to add an extra day. So February got 30 days that year. And as far as I know, Sweden is the only Western country that has had 30 days in February. So not only with computers you have leap bugs. The next big thing when it comes to calendars is time zones. And there's actually quite a lot of time zones if you not only count the UTC offset in hours, but like the local zones like Europe, Stockholm, Europe, Berlin, etc. It's over 300. And it's not only half and full hours, it could also be an offset of like 15 or 10 minutes from the UTC. So there's a lot of them. And they actually change more often than you think. It's a lot of changes every year. And they can change because political reasons, or maybe a country ceased to exist, for example. And of course, the daylight saving time changes as well. And how do we keep track of this? Turns out there's a database that is in the public domain that keeps track of time zones, leap seconds, and daylight saving time. And this actually started with a bunch of enthusiasts keeping track of this. And especially this guy, Paul Eggert, has maintained it for, I think it's like last 20 years or so. And it contains all calendar information for time zone, leap second, daylight saving time since the 1970s for more or less all regions in the world. And it also contains some historical data from before 1970. And it is used in almost all operating systems and libraries around, including the Stud Chrono library for C++, which I will come back to. And since this is a database, I downloaded it and I looked at the Swedish entries, and it wasn't that many. These are the time zone changes in Sweden. And you see in the beginning, in the 1800s, our offset compared to Greenwich was 1 hour, 12 minutes, and 12 seconds. Because we were following the sun and at the observatory somewhere around here in Stockholm. And then in the year 1900, the offset changed to 1 hour and 14 seconds, which is like almost Greenwich time, but still good enough. And then in 1916, we decided, okay, we're going to be 1 hour offset from Greenwich, which made things simpler. And then in the 1980s, we introduced daylight saving time in Sweden. So not too complicated, but still, if you need to calculate like a day or duration back in those times, you actually need to think a little. Another example is Germany. This is only the daylight saving time changes over, this is over 2 years, no, 3 years after the Second World War. That many changes, and they even had the Soviet time for a short while there. So basically, time calendar is actually pretty complex when you think about it. How can you then use time zones in C++? The StockholmCpp library added time zone in C++20, and you need to use, and it is using the database I just showed you. And you need to use GCC 14.2 or later to actually have support for it. And you can use it like this. And this is something I didn't know. You can actually update your time zone database, the local one, at runtime. Because think about it, if you have a very long-running application like a mainframe, some bank system, for example, the time zones will change in the world. And your application might need to live with that. So you might need to reload it as you actually execute your application. And you can also query the version of the local database. And on my computer, it's a 2025B version, so we're on the second release for this year already. And you use the time zone like this. You locate your time zone, like the one in Stockholm. I added a few example dates here, and these are the same dates as I showed in the Swedish database before. You iterate over them, and you use the getInfo function from StockholmCpp to query the time zone information for that particular day, because remember, the time zones change over time, and the output is actually the same data as we saw in the database. So StockholmCpp actually works with the IANA time zone database, which is pretty cool. So the next thing, representation of time and date, that's also a common source of mistakes and errors like this. What does it mean? It can be a lot of different things, and it's very unambiguous. So without any context, it's very hard to interpret this, and which just makes a mess if you have I/O operations, of course. So there's a solution for that. There's a standard from the ISO organization called 8601, and it is used for data interchange when you have dates, times, duration, and most representations when it comes to calendars and times. And it is used for, it is the basics for a lot of other standards as well, used on the internet especially. And it's using the Gregorian calendar, which is kind of the calendar that everybody uses in the Western world, at least. And some examples, this is a compliant date and time representation in the basic format, which is a little bit hard to read. So there's an extended format where you have delimiters. And this looks pretty much like how we write date and time in Sweden, with the additional T, of course. You can also have bigger precision. In this case, we added milliseconds, for example. And you can even have hours, point, and decimals if you want. It's actually quite flexible when it comes to that. So you can have an almost infinite precision in your time. You can also add the UTC offset. And if you look carefully, you see that this minus sign is not the same as this, because this is a minus sign, and that's not what you type on your keyboard. This is a hyphen minus. So, and the minus sign is not even in the lower 127 ASCII range. So it's, excuse me?
That's really crazy.
Exactly. Yeah.
Write a unit test for this.
Exactly. Yeah. Anyway, yeah. Again, a lot of research or a lot of potential failures here. You can also specify a date like the year and the number of days since the beginning of the year, and the same with weeks, for example. So how do you use this in C++ then? this has actually been around for a while. You can use the standard formatting string. Now you have like the stud format is supported, and there's no like universal ISO 8601 formatting string, but you can use the %f and %t and get a compatible string representation. And it looks something like this, for example. You can go the other way around by parsing time and date, and that is supported in Stud Chrono. Let's see, you have this one, Stud Chrono parse, and it's using the same formatting strings as when you generate a timestamp, for example. So if you run this code, and you can check if the time is valid, and it turned out that this was parsed as a valid value. So you do have a lot of time and date support in C++, and especially since version 20 and onwards. Some recommendations to avoid all these kind of mistakes and issues I just talked about. Use a time library, Stud Chrono, or there's other libraries as well, but now you get it for free in the standard library. Choose your test data carefully. Check all the corner cases and all the weird days, leap days. Like you even have invalid dates, like time that doesn't exist, for example, when you move the clock forward during daylight saving time, for example. Mock system time for testing could be useful, especially in an embedded system. Agree on representation, use the ISO standard, for example, if you exchange data. And if you calculate duration, use a monotonic clock. Otherwise, you might end up in trouble. And this is, of course, not only for like calendars and time, but it's like, in general, things you need to think about when you deal with time and computers. And then, of course, you have like synchronization and a lot of other things as well that I won't go into here. So back to my little issue with my microwave oven. Is this a valid representation? And the ISO standard says, yeah, it was supported in 2004. And when you read a little bit more, you see that it's no longer supported in 2019. And then in 2022, they actually reintroduced it a little bit. You can use it to indicate the end of the day, but you can't use it to represent a time of the day. So it's very complex, again. So the conclusion is this a valid way to show midnight? Nah, not really. It used to be okay, not so much anymore. Thank you.
If you get the leap second on that particular day?
Sorry?
Even if you get the leap second in that particular day?
No, that would be 23 hours, 59 minutes, 60 seconds.
60?
Yeah, 60 seconds. Yeah, so this would still not be valid. So, thank you.